Okay, good day, great Golf. So we are looking on to what projectile of motion, projectile of motion 2. Okay, where we are going to look into graphs. We're going to check the graphs for the displacement time graph, the velocity time graph, and the acceleration time graph, as you can see there. Okay, so this is part of the revision. Now, what you need to understand here, when you have got, we have the position, which was the displacement here, okay, displacement and what called and your time there. So this actually is actually showing you what is it, displacement here, okay, displacement, and what we're having here, change in displacement over change in time gives you a velocity, or what we call speed, okay. Okay, so in this case here, we have got what called a gradual increase of speed, okay? So we've got the same change here, same change in distance as time as well. So that's why you see we have got what called a straight time there. So there is same change there, okay? So it means that there is a gradual, gradual increase in speed in this case. And what we have there is that our gradient is the same. Our gradient is the what? Our gradient is the same. So this maintains, continue to cover same distance in same time, okay? So what we have there is that acceleration now becomes 0 because there is no change in speed in this case. There is no change in speed when you have a straight line like that, okay? So velocity does not change in this case. So velocity is constant. So we've got constant velocity, okay? Constant velocity, constant v in this case. Then what we have here is that when acceleration is above 0, it means that you are increasing speed gradually. You increase speed, and when I increase speed, it means that the distance that you covered, okay, at a given time, okay, at first, does increase, okay, does increase with time. So you start to cover more distance in a less time, more distance in less time. So you're actually increasing speed. You're actually increasing speed in this case. So in this case, that's acceleration, and acceleration will be above 0. Okay, and your velocity now, it's actually increasing in this case. So the velocity is it's actually it's increasing. Then when you are being asked for finding instantaneous velocity, this is a velocity that you find by drawing what you call a tangent, okay, a tangent to a point. Let's say it's velocity, what you call, we are asking about to find the instantaneous velocity when t is maybe when t is 2. Let's say yes, there is 2 there. It means that what you need to do here is just to find the gradient of that line. That's what you do here. You just have to draw like that, okay? Now, that's what we mean by that. Now, here, negative acceleration. In this case here, what you're doing, we can say you are maybe approaching you're approaching maybe a robot or a stop sign, okay? So what you do, you actually gradually decrease your speed. So now when you are decreasing the speed, it means that this distance that you are covering, okay, at a given time, within a given time, it's actually decreases, okay? The distance that you're covering within a given time, it actually decreases. That's why you see your curve is actually curved like that, okay? Then it means that here you are decelerating, you are reducing speed. That's why acceleration becomes it's less than 0 in this case, okay? Now, let's move on to velocity time graph. Now, velocity time graph, we've got velocity and we've got what we call in time there. And what we have here is that when acceleration, like we said, when velocity is constant and time changes, it means that you continue to move with the same speed over time, isn't it? And what we have there is no change in velocity in that case. So acceleration becomes 0 in this case. Acceleration becomes 0. So acceleration in this case here is actually 0, like what we have on top there. Now, then when you move into velocity time graph, now when you gradually increase speed, gradually increasing speed, it means that we have what we are doing here is our acceleration is actually above zero. There is change in speed here. There is change in velocity over time. So our acceleration is actually what called zero, above zero, sorry, and it is the gradient. Remember, it is the gradient. It is the gradient. So here, the reason why we have zero here is because there is no change in y. There is no change in y. So change in y actually is supposed to be change in y over change in x. Okay, to find the gradient, and in this case is 0 over x, which becomes a 0. Now, here what we have here, remember, is we are increasing what called speed, and our acceleration is actually greater than 0. Now, when acceleration is above 0, like I said, you are decreasing speed. You are decreasing the speed. Now, it means that when you're approaching a robot, you're approaching a stop sign. So what happens is that you are decreasing speed. You're decreasing speed from 50, then you go on to 30, you go on to 40, sorry, you go on to 20, 10, then until you stop like that. So our acceleration in this case will be less than a 0. What we call this? We call this decelerating. Decelerating. Okay. Deceleration. Okay. Deceleration. When I talk of decreasing speed, that's deceleration. Okay. Now, so it means it's a negative acceleration in that case. Now, here, acceleration time graph. Now, acceleration, remember, is change in what you call change in change in velocity over time. Now, here we've got acceleration in our time. So, since we don't have we can't have any change in acceleration, doesn't give us anything, okay, over time. So it means that here we actually have a straight line on what called acceleration. Okay, so just remember this: when you are increasing speed, your acceleration is above 0. When you are decreasing speed, its actually acceleration is below 0, meaning it's negative, like what we said. And another thing that you must remember here, just going to show you something here. When you are choosing what is it, like for acceleration due to gravity, G, okay, acceleration due to gravity, this one, gravitational acceleration, which is 9,8, okay, meters per square second, like that. Now, in this case here, what we are saying here is that the G, when you choose, remember what we said, you must choose either going up as positive or going down as positive. So if you choose to say, all right, going down, because acceleration and this due to gravity, remember, it's attraction of the earth, and earth is down, isn't it? Earth is actually down, so it's actually going down. So here what it means is, if you choose upward to be positive, okay, if you choose upwards to be positive, okay, remember always this x, the what called gravitational acceleration, x downwards, it does this one, x downward. Okay, so if x downward, it means that it's positive, like that. That's how it is, 9,8 meters per square second. That's what you must always remember. So it's x downwards. Now, if it's x downwards, now if you to say, I'm choosing my upward as positive, it means that here your acceleration here will be negative 9,8 meters per second, per square second. Okay, so in this case here, in a graph, you are saying if you have to draw a graph there, your graph will be like this, negative 9,8. Okay, then you put 0. Then we are saying this is our acceleration. This is our acceleration going there, and this is our time going there, and our acceleration will be negative like that, negative 9,8. Okay, so just remember when you're doing your calculations. Okay, now on this case here, if you choose downward, so here it's upward, positive. Then if you choose downward positive, it means that your acceleration will be plus 9.8 meters per square second. Okay, that's what we have there, because you choose downward as positive. Okay, now what it means here, in this case here, your graph there, actually your graph will look like this. Okay, time, and you've got acceleration there, and your graph there will look like this, 9.8. Okay, acceleration meters per square second, acceleration meters per square second, like that. That's what we have there. So your graph will be like that. Your graph will be like that. That's what it means there. Okay. So let's get to see other graphs that when you're throwing an object, when you're throwing an object. Let me see. Okay. So here, let's look here. When you throw something down, okay, when you vertically downward projectile, when you throw something down now when something is moving down towards the surface, now there are two scenarios here. Either you can choose your upward as positive. Remember, you choose upward as positive. Now, if you choose upward as positive, what's going to happen now? It means that whatever value that you start with, okay, whatever value that you start with, it's gonna be on top here, okay. And what we are saying there, when you choose it, what called upward is positive, it means that your what is it? Your distance here, is actually decreasing, isn't it? Actually, distance is what called decreasing from the top here, okay, to what? To this point. So it's gonna move like this. So you are dropping something. So it's actually dropping from a higher what you call from top there. So it means that your meters, if it is 2 meters upward, okay, it will be up like that. It will be 2 meters, positive 2 meters. So let's say you're dropping something which is which what you call a height of 2 meters. Okay, it means that that's where your 2 meters will be. So you can put here your 2 meters there. Now, because you're considering that the ground is down here. That's what you mean by saying upward is positive. Now, when you say downward is positive, okay? Now, when you say downward is positive, we expect that when you're dropping something, we expect to say, all right, now when you're dropping it, you're saying downward is what called, what is it? Downward is positive. So we expect to see the 2 there. If downward is positive, what does it mean? So it means that now when you're dropping something, we are expecting an increase. Okay, we are seeing an increase, or yeah. So what we're doing here, we are going to say, all right, in terms of our distance here, our distance starting from -2, and we are seeing that it's actually an increase going up like that. When you choose downward is what called is positive. Because downward, you're saying if downward is positive and you're dropping it down, it means that your down there is actually the highest value, or what yeah, that's the highest value there. So when you're dropping something in terms of height, it's actually increasing because you're dropping it, because you said downward is actually positive. So we expect to see any increase there in terms of position. Okay, we said we expect to see an increase, which is different from what we have here. When you're dropping down here and we're saying upward is positive, like what we always imagine, upward is positive. It means that you are standing at whatever you're dropping it from a higher level, okay, from a higher value, which is 2. Now, when you say downward is positive, it means that what you are doing there, it means that when it's coming from the top is actually the negative part. Okay, the top is actually the negative part, and you are going down, and downward is your positive part. So you're actually increasing. As you're going down, you are increasing. It's actually the value is increasing. Okay, that's what you just have to master here about these two here. Let's go to the next one, the velocity time. Okay, so here what we have on the first graph here, velocity time graph. Okay, that's our velocity there, and you can see that, all right, if you are dropping something, okay, vertical downward projectile, you are dropping something here, okay, then now when you are dropping something here, it means that your velocity here, what happened to the velocity time graph, because you're going down, is actually negative. Okay, it's actually negative. It's actually negative here. Because now, why are you having zero here? Because remember, when you are dropping something, it starts with the initial velocity of zero, unless it is thrown. So it's actually, it starts with the velocity of what? Of zero. Okay, then now, when it's going down, because it's opposing motion, because remember, force of gravity is it's opposing motion. So what is happening here is that it's going down, it's decreasing. Okay, then when it is velocity, when you consider that the going downward is positive, you actually see an increase in velocity. In that case, you actually see an increase in velocity. That's what you see there. You're actually seeing an increase, because remember, your object is going down, and you say my going up is my positive. So this is actually opposing motion, direction of motion. Okay, the positive direction of motion. Then in this case here, when you're saying it's going down and you're dropping it down, it means that it's the same way in the direction of motion. So it means that your velocity here will be actually is going up, it's increasing in this case, and your acceleration now in this case will be actually above zero in this case, and acceleration in this case will be below zero, like what we have discussed here up here. Okay, to say when you consider upward is positive, when you're dropping something, your acceleration due to gravity, because it's always x downwards, it will be negative. When you consider upward is positive, then when you consider downward is positive, your acceleration will be positive 9.8. Always remember that. So it's very good to determine which side is positive before you tackle the question. Now, so it means that your V will be a positive, it's going up like that. Okay, and your acceleration now becomes what? I'm just going to repeat what I've drawn up here. Okay, so what we have there is that your acceleration here, when you're dropping something, acceleration, we are dropping it down, it means that, and you consider you consider upward is positive, acceleration due to gravity will be negative here. Okay, always remember that. And when you, so it means that in your equations, you must know you must actually substitute the right value. Okay, in equation of motion, you can actually catch up on our projectile motion 1, where you actually see the use of those equation of motion. Okay, now, so here going up, if you consider going down is positive, it means that your acceleration due to gravity will be actually 9.8, because in this case it's not opposing anything, because we are saying acceleration itself 9.8 is actually going down. It's attracting what called any object to the earth or downwards. Okay, so that's what we have there. Now, I have left something here. When you want to find the area, okay, sorry, the area, when you want to find, not the area, the displacement, okay, which is change in y, okay? Your change in y on your velocity time graph, you must know that it's area under the graph. Area under the graph. So what must you use? It's just the area of a triangle. Area of a triangle. Now, area of a triangle, how we do find it is half base times height. Okay, I wish we could find also some other examples that you can actually learn from. So this is how it's supposed to find area under the graph. So if you are to find area under the graph here, so this area under the graph tells us what? The height, okay, or a change in y. That's what we have, the area under the graph here, area under the graph here. So area is equal to change in y. That's what it means. So if you find area there, it means that that's your what you call change in y in that case. Okay, so let's see what is it on the projectile. Okay, so position time graph here. Now it's a projectile motion of up and down. So we are throwing something up, then it comes to the same level. Okay, you throw it up, then it comes back to the same level. That's what's happening. Now how would you present that? Now, if you are throwing something up and you consider it as, what is it? is what you call, you consider upward is positive, it means that when you throw something up, it's actually going up, okay, to a certain height above ground, okay, then it comes down. Now, when the reason why it's going down like that is because now it's coming back to its original position. So this actually becomes our reference point. So this is actually the reference point. Okay, that's what you're doing here. So it goes up, reaches the maximum height there, and comes back to what called to its original position. Remember, reaches the maximum position from our previous lecture. That's where velocity is equal to 0 there. So we want to relate this when you move on to the velocity time graph. Okay. Now here, position time graph here in this case, okay, it's what we are saying. Downward is positive. Downward is positive. So if downward is positive, it means that when you throw something up, it's actually going down. It's actually, its height is actually decreasing. It's actually going down like that. Then reach maximum, then it comes back like that. That's what we have there. That's what we have there. Okay, that's how you must always remember. So going up, if downward is positive, it means that whenever you are throwing it up, it's actually decreasing, because going up is actually negative. It's actually going against what called, it's actually negative. Then going down, okay. Now here, this object means that here is going up, okay, because you consider it as positive, downward is positive. So when it's going up, it's actually opposing direction of motion that you choose to be positive. Now, when it's going down now, that's when it's increasing now, because you choose downward is positive. That's when it's increasing its value. Okay, that's why you've got what called this type of this shape of the graph. Okay. Now let's move on to the velocity time graph. All right. Now, what do we have now? We're going to say right now a velocity time graph. Now, velocity time graph. Now, you consider positive, going up is positive. That's very good. Okay. But now, understand something here. What we're going to have here. I'm going to say, all right, we have got velocity here, okay? And we know that when you throw something up, like in this case here, it goes up. Now, remember what happens to your velocity here. When you throw something up, velocity decreases. So velocity decreases. In this case here, velocity decreases. Okay, velocity decreases as it goes up, okay, until it reaches 0. Now, what are we going to do now? So it means that we have a specific velocity here, okay? Now, that you start with when you're throwing it up, it starts with a certain velocity. Now, when it's going up, what's going to happen to it now? It will reach what? It will reach 0. And here, it determines the maximum height. So this one determines the maximum height. When the maximum height, velocity is 0. So V is equal to 0. That's what we know. So now from there now, what happened to the velocity? Velocity starts to increase. But now it's increasing way now because it's now moving on the opposite direction. So it's now moving on the opposite direction. So it becomes negative now. So it's actually increasing in the negative direction there. So what happens now? You have a straight line like that. That's what you will be having there. Then what we'll have there is mean that from this point here, okay, so it means that V here is positive. You've got the positive velocity and you've got negative velocity here. So here is negative, here is positive, okay? Now, what do we have here? We have got the area here that we know that this one is negative. That's what you know, okay? So understand this very, very well here. Understand this very well. When it's going up, you're throwing it up. So when you throw it up, what happens to its velocity? It decreases as it goes up until it reaches 0, okay? Then from there, it comes down again until it reaches what you call its minimum, what you call its velocity. So in other words here, if we are to say this velocity here is 10, okay? It means that at this point also, it will be negative 10. Because remember what we said, the velocity it leaves the whatever position it leaves, it will actually have the same negative velocity when it's come back on the ground. Okay. Now, let's move on to the next one here. What we have here, we're going to say, all right, now if we are to consider upward, downward is positive, it means that already your velocity is actually what called upward, downward is positive. Already your velocity is negative. Initial velocity here is negative, okay? Is negative. So you start with the negative velocity. Then as it goes up, it is actually from negative, okay? What happens now is that it decreases. Its velocity is decreasing, okay, to 0. It reaches 0, okay? Once it reaches 0 there, what happened to it? It comes back. When it's coming back now, it's coming down now. Remember, here, you throw it up. Now, when it's coming down, what happens to its velocity? It's actually increasing in this case, okay? So it actually increases in the positive direction there. So it means that that's how your graph will look like. Now, what we have here is V, positive V, okay? Then we have our area there. Here, our velocity is positive. Here, velocity is negative. Okay, that's what you always have to remember then. Now, remember what we said here. So this area here, area of velocity time graph, is actually shows us what called displacement. Okay, so the area is equal to change in y. So whenever they ask you area, you know that you're going to add these two triangles, area of these two triangles, okay? Area of this triangle, so A and B, okay? So change in y is equals to area A plus B. Simple. That's what you need to remember. Okay, that's how you need what you need to remember there. Okay. Now, what else is left there? Okay, let's see another scenario. Okay, now what we have here is that projectile motion up and downward past the starting position. So you're standing maybe on a roof, okay? Then you throw something up, a tennis ball upward, then it actually passes you, then you fall on the ground, okay? So down on the ground, okay? You are standing on the roof, so it actually passes you. So you are standing here, okay? You throw something up, then it passes you here, okay, where you are on the roof, then it goes to the ground, okay? So that's what we're going to talk about now. Now, when you see this now, okay, it means that, all right, it's gonna pass the original, the what called yes, should I say, yeah, initial height here, okay, and goes to what called down to the ground. Now, what did we say about the time symmetry? In terms of time, you can see that in terms of time, it actually take more time to reach to reach the ground there. Then another thing again is that what is it? Another thing is in terms of velocity now. In terms of velocity, we expect the velocity to be the same in this same height, okay? So same height here. So it means that when it passes the roof, when it reaches the level of the roof, velocity, this velocity will be equal. Velocity will be equal, okay? But now, what happens now when if it continues to move, if it continues to move down, it means that its velocity continue to increase. So I want you to understand that concept as well. So now let's get to see position time graph here in this scenario. What we have there, we know that we chose our positive, upward is positive. We are throwing it up, so we'll throw it up like that. Okay, then it reaches a maximum height, then it comes back. But now, does it stay? Does it stop here? No, it's actually continuous. Okay, so it does continue like that. So it until it reaches what called the ground. Remember, until it reaches the ground. So your reference point here is 0. And remember always also that displacement in this case for these two here will be equal to 0. Okay, between these two will be equal to 0 because there is no change in position in this case. But once it passes the initial position now, it means that you start to have your what called your displacement in the negative direction. Okay, now what we have here, we know that, all right, we choose to be our downward is positive, okay, and we're throwing it up. Oh, it's opposing motion. So what must happen? It must go down, okay? It must go down, okay? Now when it goes down, reaches maximum, then what does it do when it's going down now? It's actually increases. It's actually going to increase. It's going to increase, it goes on like that. That's what we have there. That's what you need to know about that called the position time graph. Okay. Now the tricky part here is here. What I was trying to explain there, what I was trying to explain with this graph here, to say, all right, now we start with a velocity that is up there. Okay, so let's give this velocity v, and let's just say this is maybe 10. Okay, let's say it's 10. Okay, now when it's 10 here, what happened to it? You throw it up. Okay, it comes back. What call it? Reaches. Now when it reaches, when it's here, it reaches the maximum. Always remember, this is the maximum height. Okay, where v is equal to 0. Always remember, know that, always know that. Now reaches maximum height. Now what happens to it? Now it comes back. It actually, what call, it's actually continues there, continues like that. Now understand something here. At a certain point here, when it's 10 here, that will be the same height there. Okay, so here you're gonna put negative 10. But now, because this is actually passing the roof, it's going to the ground. So it means that its velocity continue to increase in this case here. So it will maybe reach up until maybe negative 15. Negative 15. So that's what we end up having here, that on this side here, we have, what is it? We have a larger area here, okay, than this. Why are we saying that? Because the height is actually also bigger, okay? The height is actually also larger there. Now, because we've got an extended height here, so the what you call area is bigger here, but here the area here for area for A and B is the same. So we can say here area A is equal to B in this case, okay? Because that's what we have there. But in this case here, we don't have that. We don't have that. We can say, all right, this is our A and this is our B, okay? And we can say that area B is greater than area A. Why are we saying that? Because height here, change. We've got high change in Y here, Y, BY, okay? Okay, so we have got the length, okay, height to go down, okay? Height to go down here is actually higher than the one to go up because you are standing on top there. Now, so, but remember always the area change in Y is still equal to area of A plus B. That's what we need to always remember. Now, in this scenario, let's move on to this one again. We're going to say, let's start here maybe with negative 10, okay? We start with negative 10, put a 0 here, remember? Now, what happens to it? It goes there to 0, its maximum height, then it goes up, it extends there. Now, when it extends there, what happens? We have got 10 here, okay? But still, it goes on to 15. That's what we have there. So we have, what is it? We'll have a larger area here. Okay, so here we have got A and we have got B. Okay, now in this case here, you can see that the velocity continue to increase. Velocity continue to increase until it reaches the ground. That's what we mean by that. Okay, so I hope you guys understand this very well. I hope you guys understand it very well here. That this is actually shows that the height here, height for B, height is bigger height, okay? It's bigger height. Now, what we can expect here, you can see that here, this change here, okay, is actually maybe high, okay? Here is for B, and here is for A. That's what you can say. There is for B, and that one is for A. That's what we have there, okay? So let's see what's actually in store for us there. All right, something to remember here. Now here on top, the objects force from rest. Remember what we said here. Initial velocity will be equal to 0, and when you consider upward is positive, what's happening there is actually decreasing in this sense. Okay. Now, so this is what we have here. Initial velocity is 0 because it's dropped from rest. Remember. Now, the next one here is saying object thrown downwards. So if we throw something downwards, mean that it's now having an initial velocity, which is not equal to 0. Okay. So if you're throwing something, what call is different from dropping. Okay. So we'll expect to have a certain what call a velocity. A certain velocity must have a certain velocity, which will be your v initial. And always remember that when it's going down, okay, it's actually increasing its velocity as well. Okay. So its velocity here will be having your final velocity there. Then in this case, again, if you consider downward is positive, when you're throwing something downward, it means that its velocity here is starts with a certain velocity, then actually increases until it reaches what you call until it reaches the ground. So here it means that that's where it actually on the ground. Okay. So let's see again what we can find again. Okay, so now let's look on the bouncing ball. Okay, a bouncing ball. So now when you check, a ball is bounced, okay, here, what we have here is that, let's say you throw a ball, a tennis ball into the air, it goes to the ground, then you throw it into the air with a velocity, okay, then when it goes down, it passes the level where you threw it, okay, then it reaches the ground, okay. When it hits the ground, it will actually bounce, okay. It hits the ground first, then it bounces back into the air. But have you noticed that the height that it reached first when you threw it, okay, then when after bouncing, its height continues to decrease. Like as you can see there, its height continues to decrease until it reaches until it's actually stayed on the ground. It's actually on the ground until it no longer bounce. So want to know what's actually happening there. Remember from momentum, okay, there is change in momentum there, and once the ball is in contact with the ground, okay, it actually loses some of its energy, because remember the moving energy is kinetic energy. So once it is bouncing on the ground, it's the ground itself is exerting a force on the ball, okay, and that force, okay, if the time, okay, that's why you see if you hit the ball, if the ball is hard, maybe with a greater speed, you find that it will take less time on the ground. So it actually experiences less force. So here what will happen is that the time it takes on the ground, you can see that, sorry, the force that actually the ball, the force acting on the ball here are two, which is one force of gravity and the other one is force of the what? Of the ground, okay? So the ground exerts a force, which in other words in the normal force, okay? Opposite force there, which is upward force. Then that upward force, okay, is equal to your F net, sorry, that upward force is actually greater than the FG. That's why you find that it's actually your upward force actually take it up there, okay? It actually exert what call a bigger force. That's why you see it's continuing to what call to bounce. Now, so it means that we will be having a F net there. F net should be your FB, which is the force exerted by the ground, minus which was plus the FG, which in this case will be a negative. Now, so when the ball hits the ground exerts an upward force, which we were talking about here, on the ball for a short time interval, which is change in t. FB is larger than the downward force, okay, like I just said here. Therefore, we have F net, okay. Then the ball bounces, okay, experiences impulse, okay, which is change in momentum, okay. So the first momentum it had when it actually hit the ground is actually what we call different when it leaves the ground, okay. So it means that when it leaves the ground, it's actually having a less velocity. Now, impulse here is because F net times change in time, which is change in momentum, okay. So ball have maximum velocity and kinetic energy just before it hits the ground, okay. Now, during each bounce, some kinetic energy is converted, sorry, into other forms of energy, which, for example, heat. That's why you can hear the sound of a bouncing tennis ball, and also what called heat and deformation of the ball. Now, so when the ball bounces back, it will be having a smaller velocity. So we expect what called the ball reduce what called to reduce what called its speed and actually to go into a stationary there. Now let's see the position time graph, how you have to represent the position time graph here. Now understand something here. When you take positive as upward positive, it means that it's going down there, okay? Then now we have a space here, okay? We don't have a continuous graph here. We have a space here. So this space actually shows that there is a time where your ball is on the what? On the ground. So this time increases with what called as the ball bounces. So this time increases. So it means that the time the ball takes with what called on the ground, okay, is also determined by the what called the height it takes and also the velocity of the graph, the velocity of the ball. So the velocity of the ball decreases as it goes down, as it goes like that. So in other words, here, with time, the time it takes to on the ground, it will increase up to a point your ball will remain on the ground. That's why we have this time here. This is the time it is on the ground, okay? So this is the time interval it will be on the ground. So that this one, always remember that this one is because we take our upward is positive, then this one, our downward is negative. And you can see the trend is just the same. Now, the velocity time graph here, as you can see there, when your ball goes up, it reaches what is it? When it's bouncing, okay, it goes to the ground, it bounces. So now when it's bounce, okay, now here, remember, it's on the ground, it's not moving. So there is no, that's why you see there is change this time here. This time where it's on the ground, okay, there is no movement there. Then from there, it starts again with an initial velocity, okay, which is actually above zero, okay, which is actually above zero. Then what happened to it now? It actually increases as it goes down. Then it reaches its actual maximum. Then it goes down again. Then it just continues like that. That's what we have here. So always in its maximum, it's actually the velocity is zero, remember. But now, we want to know why is it here we don't have final velocity as zero. Okay, why is the final velocity zero? Remember again, when the ball hits the ground, it will be having a certain velocity. Okay, it will be having a certain velocity. That's why we have velocity of certain amount here. That's why it doesn't come to zero. It doesn't come to rest to zero here. Okay, we'll be having a certain velocity when it goes to the vertical, when it remains on the ground there. Okay. So the final touch on the ground, it will be having a certain velocity, which will be actually basically less than those two velocity when it was bouncing on the ground. Okay. Now, then we move on to the acceleration time graph. Acceleration time graph here, as you can see that what we have here is that this acceleration, okay, on the vertical, we have constant acceleration here. But remember, when it bounces back, it's having it's experiencing that it's accelerated by the force again of of the ground. So this is actually the influence of the force of of the ground that we have here. So it actually increased the force here and it increased the acceleration because of the F net that we spoke about. Okay, so this is, you just have to learn how to construct your graphs here. Okay, so this is actually the end of of our lesson. Okay, this is the end of the lesson. Thank you so much, guys. Don't forget to follow us on Facebook, Instagram, and Twitter, and also subscribe to our channel for updates. Okay, so until next time, guys. So the next lesson day we'll be looking on the questions that involve construction of graphs. Okay, so all the best. Cheers.